Laboratory work number 5. Statistical checking hypothesis, calculation of goodness of fit criterion chi-square, Pearson criterion of statistical population feature distributed by normal law. You can learn the theoretical information in your laboratory work. In few words, in this work you have to create the model of distribution of your statistical data for sample A and sample B and compare this model with the actual distribution of your variation series. In conclusion, you have to explain if this model is significantly different from your actual data. This difference can be estimated by the goodness criteria. The most frequent criterion used in this case is the Pearson criterion. So let's create model. First of all, we have to work with the sample A as usual. Copy the variance value and their frequencies. It's not a problem. Then you have to calculate the PI values for your data. The PI value is the probability value. It's calculated with the help of the function norm_rasp. In this function you input norm_rasp, the value x, this is the variant value, the average value, this is a simple average value for the sample A 2.8 in my case and your average value in your cases. Standard deviation value, this is sigma, стандартное відхилення, standard deviation, this is sigma. For the sample A is simple calculated. And 0, we consider 0 for the sample A as parameter of integral. So we have already import these parameters and just multiply your formula. Then you have to calculate theoretical frequency. Theoretical frequency is determined as the fraction of sum of all the frequencies and their probabilities. Don't forget to fix the summary frequency with the help of F4 key. Then you have to calculate this expression for all the variance. You have to determine the difference between absolute frequency, theoretical frequency. You have to determine square of it and divide on the theoretical frequency. These calculations are required for estimation of the calculated Pearson criterion. We determine it as the sum of all our expressions in this column. So we have already calculated the Pearson criterion. Then we have to estimate the critical Pearson criterion. The Pearson critical criterion is calculated according to this formula, chi2 obr. In this formula we input the probability and freedom degrees. Probability we define as the difference between 1 and your significance level. Significance level can be chosen as 0.95, 0.99, 0.91. These three values are used in the most cases. We checked the probability level of 1 minus 0.95. So we input here is 0.05. The freedom degrees we consider 5 because according to the rule it is determined as n minus 3, where n is the number of your variance. And now we have calculated the actual or calculated Pearson criterion and critical value of the Pearson criterion. Now we have to determine the difference of them. So we can see that critical criterion is greater than calculated criterion. It means that according to our protocol of the work, we can make conclusion that our model adequately describes the actual distribution law, because the calculated value is less than the critical value. The calculated value is less than critical value with the chosen level of reliability. Our model is adequate. And now we have to build the graph of our actual statistical distribution and our model. So let's try. You have to build the diagram. First of all, you have to select the data, select absolute frequency, press Ctrl and hold it, and select theoretical frequencies. And now you can create the graph in such a way. For the best description of your results, we can change the type of diagram of theoretical frequencies. You have to change the type diagram. And now we can see the visible difference between your actual frequencies and your model. And difference between this model and your actual distribution data is reliable. We can be ensured in it as we have already calculated the Pearson criterion. So let's make formatting of the diagram.